Hey guys, we're going to continue with matrices now. And today we're going to start with multiplying matrices. When you multiply matrices, you multiply rows by columns. So you're going to multiply the first row of the first one by the first row of the second one, then the first row by the second column. I think I said row for that one, but it's column. So it's a row by a column, and then that same row by the next column. When we multiply matrices, we've got a 3-row by 4-column matrix, and then we've got a 4-row by 3-column matrix. And I know that I can multiply these because the inner dimensions match. And it's the outer dimensions that tell me the dimensions of the product, 3 by 3. So I've just got a matrix here with variables representing each element. We're going to turn those variables into numbers. But I've got a 3 by 4 and a 4 by 3. Inner dimensions match, so I can multiply. Outer dimensions tell me 3 rows and I put a 3 here, but that should be a 2 by 2 columns. This is 4 by 2. So I've got a 3 by 2 set of outer dimensions. That will be the dimensions of my product. Okay, so here's how we do this. We are going to multiply this first row by this first column, one element at a time, and we're going to start with the first elements, 2 times 6. Okay, then we're going to move over and down, 4 times 0. And then over and down again, 1 times 1. And then over and down one more time, 3 times 2. Okay? And I'm going to add that all up. So I've got 12 plus 4, which is 16, plus 1, which is 17, plus 6. I'm sorry, I've got a 0 here. So this is 12 plus 0, which is 12, plus 1, which is 13, plus 6, which is 19. So that element A is 19. Okay? Then I'm going to multiply that first row, that same first row, by the second column. So I've got 2 times 5. 4, so I go over and down, 4 times 2. Over and down, 1 times negative 3. Over and down is 3 times 1. And I'm going to add that all together. So I've got 10 plus 8 plus negative 3 plus 3. And that is a total of 18. So this second element is 18. So now I've multiplied the first row by the first column and the first row by the second column, and I'm all out of columns. So I'm going to move down to the third row. So the third row by the first column, 1 times 6. Over and down, 3 times 0. Over and down, 2 times 1. And over and down, negative 1 times 2. Okay, so I've got 6 plus 0 plus 2 plus negative 2 for a total of 6. So my next element is 6. Okay, now I need to do that same row by the next column, 1 times 5. 3 times 2. 2 times negative 3. and negative 1 times 1. So that gives me 5 plus 6 plus negative 6 plus negative 1, which is 4. So my element here, D, is 4. And now I move on to the third column, or the third row of the first matrix. So I have 5 times the first column, 6. Over and down is negative 2 times 0. Over and down, 3 times 1. And over and down, 0 times 2. So I've got 30 plus 0 plus 3 plus 0 for a total of 33. And then the same last row by the last column. 5 times 5. Negative 2 times 2. Three times negative 3. And 0 times 1. So we've got 25 minus 4 minus 9 plus 0 for a total of 12. So that is my final outcome, my 3 by 2 matrix. Let's try another one, and this time we'll show a little bit less of the work. First of all, is this even possible to multiply? We've got 3 rows by 3 columns, and here we've got 3 rows by 4 columns. Inner dimensions match, so I can multiply these, and I know my result is going to be the outer dimensions. It's going to be a 3 by 4 matrix. Okay, so first row by first column, 1 times 4 is 4. Over and down, 7 times 3 is 21. Over and down, 0 times 2 is 0. 4 plus 21 plus 0 is 25. Okay, first row by the next column. 1 times 2 is 2. 7 times negative 2 is negative 14. And 0 times 14 is 0. 2 minus 14 plus 0 is negative 12. Okay, and then the first row by the third column. 1 times negative 1 is negative 1. 7 times negative 3 is negative 21. Not really sure what's happening to this writing as I go here. And then 0 times negative 10 is 0. Negative 1 minus 21 plus 0 is negative 22. And then the first row by the last column. 1 times 0 is 0. 7 times 1 is 7. And 0 times 0 is 0. 0 plus 7 plus 0 is 7. Okay, so I've got my first row done. There should be 3 rows, and I've got 4 columns already started. So next, I'm going to multiply the second row by each column. So that's negative 3 times 4, negative 12. Negative 2 times 3 is negative 6. And 4 times 2 is 8. So we've got negative 12 minus 6 plus 8, negative 10. Okay, second row by the second column. Negative 3 times 2 is negative 6. Negative 2 times negative 2 is positive 4. Negative 4 times 14 is, positive 4 times 14 is 56. Okay, so we've got negative 6 plus 4 plus 56, and that is 54. And then, second row by the third column. Negative 3 times negative 1 is 3. Negative 2 times negative 3 is 6. And 4 times negative 10 is negative 40. Okay? So when I combine those, I get negative 31. And then second row by the last column. Negative 3 times 0. Negative 2 times 1. And 4 times 0. For a total of negative 2. Okay, and then the last row by each column. So this time I'm going to show even less work. 0 times 4 is 0, 0, 2. 0 plus 0 plus 2 is 2. Okay, then on to the next column. 0 times 2 is 0, 0 times negative 2 is 0, 1 times 14 is 14, 0 plus 0 plus 14. Okay, then 0 times negative 1 is 0. 0 times 3, negative 3 is 0. 1 times negative 10 is negative 10. And then the last row by the last column. 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. So I've got 0 plus 0 plus 0. And that is my final 3 by 4 matrix. Okay, multiplying by a scale factor. Here's a scale factor of 3. I'm going to multiply this matrix by a scale factor of 3, and that really just means I multiply everything by 3. 3 times 3. 5 times 3. Negative 4 times 3. Negative 2 times 3. 1 times 3. And 2 times 3. That is how you multiply by a scale factor. So here, it's 5 times that matrix. So it's like having a scale factor out here of 5. 5 times 5. 8 times 5. 7 times 5. 2 times 5. Negative 3 times 5. And 11 times 5. So on the last page, we are going to do some matrix operations. We're going to add matrix A plus matrix C. But you know what? Matrix A is 3 rows by 2 columns. And matrix C is 2 rows by 3 columns. I can't add those, because remember, to add and subtract matrices, they have to have the same dimensions. So this is not possible. I cannot possibly add those matrices. Next is B minus D. 2 by 2. And another 2 by 2. Those can be subtracted. So B and D are both 2 by 2, so we can subtract those. So B minus D, we've got 5, oops. All right, there we go. 5, negative 2, negative 1, 4, minus 2, 9, negative 5, 0. Okay, so we've got 5 minus 2, negative 2 minus 9, negative 1 minus negative 5, so that's negative 1 plus 5, and 4 minus 0. Okay, 3 times A, you can always do scalar multiplication on any matrix. So there's 3 times matrix A, and now we just multiply everything in matrix A by 3. 2 times 3, 0 times 3, 0 times 3, 5 times 3, 1 times 3, and negative 3 times 3. Okay, then it's 2 times matrix D. So it's 2 times 2, 9, negative 5, 0, plus matrix B, 5, negative 2, negative 1, 4. Okay, so first we're going to have to do 2 times matrix D. So that's 4, 18, negative 10, 0, plus 5, negative 2, negative 1, 4. And now we can add our corresponding elements. 4 plus 5, 18 plus negative 2, negative 10 plus negative 1, and 0 plus 4. All right, and then our last one, 2 times B times D. All right, so we can multiply these in either order. We can do 2 times matrix B, then times matrix D, or matrix B times matrix D times 2, because multiplication is commutative. So let's multiply the 2 matrices first. Okay, so we're multiplying rows by columns. So we've got first row times first column is 5 times 2, which is 10, plus over and down, negative 2 times negative 5 is 10, so we get 20. Okay, then the first row by the second column, 5 times 9, and over and down, negative 2 times 0. 45 plus 0 is 45. Then the second row by the first column, negative 1 times 2, and over and down, 4 times negative 5. So negative 2 minus 20 is negative 22. And then the first row by the last column, negative 1, the second row times the second column, negative 1 times 9, and 4 times 0. And that is negative 9. So now we can do our scalar multiplication. 2 times 20. 2 times 45. 2 times negative 22. And 2 times negative 9.
All right, we'll finish this up by practicing some skills that we need to continue to keep sharp. So we are going to solve this 2 by 2 system, and because I have y by itself here, I think the easiest way will be substitution. So I will take this value of y and substitute it right there. So I get 3x plus 2 times 6x plus 3 equals 16. Okay, so then I'll distribute this positive 2, and I get 3x plus 12x plus 6 equals 16. I've got like terms here. 3x and 12x makes 15x. And I will take that 6 to the other side. 16 minus 6 is 10. Okay, so I will have x equals 10 15ths. And that will simplify to x equals, 5 goes into both of these 2 times and 3 times. So there is my value of x. And then I will plug that in right here. So I've got y equals 6 times 2/3 plus 3. So 6 times 2 is 12, divided by 3 is 4. So I've got y equals 4 plus 3. So y is 7. So the solution is 2/3, 7. Okay, and then number 2, I think for this 3 by 3, the easiest thing to do would be to eliminate the x's. So I can eliminate x's here by multiplying this equation by 2, and I'll write that above. 2x plus 4y minus 6z equals 6. And then I will combine those two equations. So the x's eliminate, and then 4y minus y, I've got 3y, and then negative 6z plus 2z is negative 4z, and 6 plus 1 is 7. Okay, I could eliminate the x's in the top and bottom equation by bringing this one down here and multiplying by negative 1. So I get negative x minus 2y plus 3z equals negative 3. And when I combine those, the x's eliminate, and I get negative 7y plus 10z equals negative 13. Okay, now I will eliminate with these two. Let's go ahead and do the y's. So I will multiply this equation by 3, so I get negative 21y plus 30z equals negative 39. And I'll multiply this one by 7 and get positive 21y minus 28z equals 49. And the y's will now cancel. Okay, so then I've got 30 minus 28, that's 2z, and then negative 39 plus 49 is 10, so I get z equals 5. Okay, now I will take that 5 for z and plug it into this equation, so I get 3y minus 4 times 5 equals 7. So that's 3y minus 20 equals 7. I'll add that 20 to the other side. 3y equals 27. And divide by 3, so I get y equals 9. And then I will take my values of x and y and plug them into the top equation. So I get x plus 2 times 9 minus 3 times 5 equals 3. So that's x plus 18 minus 15 equals 3. 18 minus 15 is 3. X plus 3 equals 3. And when I subtract this from the other side, I get x equals 0. So I have 0, 9, 5. Okay. Number 3, add matrix A plus matrix C. Okay, now matrix A is 3 rows by 2 columns. Matrix C is 2 rows by 3 columns. Those do not have the exact same dimensions, so I cannot add them. So this is not possible. Okay, how about matrix D minus matrix B? So we have 2 by 2 and 2 by 2. So this can be done. In order to add or subtract, I have to have exactly the same dimensions. And I do for these. So D minus B, I've got 5, 9, negative 2, 0, minus 1, negative 2, negative 3, 8. And now I just subtract the corresponding elements. 5 minus 1 is 4. 9 minus negative 2 is 11. Negative 2 minus negative 3 is 1. And 0 minus 8 is negative 8. And this is my resulting matrix.